Saishriya
and welcome to Agora Math Circle.
Before you continue watching this video, make sure to subscribe to the Agora Math Circle channel.
This is Senior Beginner, and today we are going to be learning about right triangles and quadrilaterals.
Well,
so let's get to it.
Let's start off with the basic definition of a right triangle. A right triangle is a triangle in which one angle is right, or 90 degrees. As you can see, this is how it looks. One of the angles will be right or 90 degrees, and it consists of two legs and a hypotenuse, which is basically the larger side. Now, based on right angles, we have a theorem called the Pythagorean theorem. So it's basically where both of the legs are called A and B, and the longer side is called C. So the theory says that A squared plus B squared is equal to C squared. So both of the legs squared is equal to C squared. Well, let's prove this theorem. So let's say that this is a square. We have a square and then we have an inner square inside it, in which all the sides are C. Well, we have to prove how to get the area of the inner square. Well, obviously we know that the inner square, how to get the inner square is basically the area of the entire square minus the shaded regions, obviously. So first of all, let's find the area of the outer square. Well, each side consists of A plus B. And so the area of the square is just S squared. S is A plus B, so that's A plus B squared, or A plus B times A plus B. You can distribute A times A, which is A squared, plus AB, plus BA, which is also AB, plus B squared. And that's basically A squared plus 2AB plus B squared. So we know that the area of the outer square is A squared plus 2AB plus B squared. Now we need to subtract the area of each of the individual shaded parts from the overall square. So first, let's find the area of each triangle and multiply by 4. Well, obviously we know that the area of a triangle is 1/2 of height times base, or base times height. Now, in this case, the base and height are AB, so the area is 1/2 of AB. Now we have to multiply this by 4 since there are 4 triangles. So 4 times 1/2 of AB, well, it's basically 4 over 2 times AB, and you can simplify and get 2AB. So 2AB is the shaded regions. Now we have A squared plus 2AB plus B squared. Now we have to subtract 2AB from that. So you get A squared plus 2AB plus B squared minus 2AB. Well, you have 2AB and then you have the opposite. They cancel out. And get A squared plus B squared. And the area of this squared right here is obviously C squared because each of the sides are C. So the area of this is C squared. And we also found out that the area is also A squared plus B squared. So this kind of proves that A squared plus B squared equals C squared, thus proving the Pythagorean theorem. So now let's move on to Pythagorean triplets. Pythagorean triplets are sets of values for A, B, C in a right triangle. For example, they are sets of values that fulfill the Pythagorean theorem for A, B, and C. Fulfill A squared plus B squared equals C squared. Well, there are many examples of Pythagorean triplets, but right now let's just look at 3, 4, and 5. They are values for A, B, and C. Let's just check this. Well, according to Pythagorean triplets, these 3 values should fulfill the Pythagorean theorem, which is A squared plus B squared plus C squared. So A squared, which is 3 squared, plus B squared, 4 squared, should equal 5 squared, or C squared. Well, 3 squared is 9, 4 squared is 16, and 5 squared is 25. So yes, it is a Pythagorean triplet. Now, here's another really cool thing about Pythagorean triplets. If you multiply all 3 values by the same number, let's say 3, it should also be a Pythagorean triplet and also fulfill the Pythagorean theorem. For example, let's multiply it by 3 here. So 3 times 3 is 9. 4 times 3 is 12. And 5 times 3 is 15. So, according to that, 9 squared plus 12 squared should equal 15 squared. Well, 9 squared is 81. 12 squared is 144. And 15 squared is 225. So 81 plus 144 should equal 225. And yes, it does. So that is actually true. Now let's do a small practice problem. So this is a problem and we need to find the values of x and y. Well, how can we do this? Well, we can use the Pythagorean theorem to find x and y. Let's try to find x first. Well, according to the Pythagorean theorem, a squared plus b squared should equal c squared. So x squared plus 8 squared should equal 9 squared. X squared plus 8 squared is 64 should equal 81. And when we subtract 64, you get that x squared should equal 17. So x is root 17. So it's the square root of 17. So we found x. And you can also check your work. Now let's find the value of y. So it's saying y squared plus 8 squared should equal 17 squared. So y squared plus 64 should equal 17 squared. And if you don't know it, you can multiply to find out. And you get 289. So when you subtract 64 from both sides, you get that y squared should equal to 225. And we already found that 225 is 15 squared. So y should equal 15. So those are the values of x and y. Now let's move on to some special triangles. Let's move on to an isosceles triangle. Well, something cool about isosceles triangles are that obviously we know that the base angles are equal. So these two angles are equal, right? And these two sides, obviously we know that they're equal. But another cool thing is that the altitude, which is basically a perpendicular line to the base, well, if you have the altitude right here, it causes two separate equal triangles. So it bisects angle B, meaning bisects means separates them into two congruent angles. So this angle is equal to this angle, and it also bisects the base. So this length is equal to this length. So basically, measure or angle ABM is congruent to angle NBC if the altitude is there, and angle A or measure of AM length is congruent to the measure of MC. So this is another cool thing about altitudes and an isosceles triangle. So now we're going to learn more about special triangles. Let's start with the isosceles right triangle. So in the isosceles right triangle, both of the legs are congruent, meaning that since it's an isosceles triangle, the base angles, or the angles opposite to the legs, are also congruent with 45 and 45 degrees. Now in isosceles right triangles, the lengths of the sides are A, and A rad 2. And let me show you why the hypotenuse is A rad 2 in a second. Well, according to the Pythagorean theorem, A squared plus B squared equals C squared. So A squared plus B squared, which is just A squared, should equal C squared. So A squared plus A squared equals C squared. So 2A squared equals C squared. Well, we're only trying to find C, so we have to find the square root of both sides. So C is equal to rad 2A squared. Well, A squared is a square root, so C is equal to A rad 2, which is why the hypotenuse is A rad 2. Now let's move on to the 30, 60, 90 triangle. So in the 30, 60, 90 triangle, the length of this angle, or the measure of this angle, is 30, 60, and obviously 90. Now, in a 30, 60, 90 triangle, this will be the lengths of the sides. X rad 3, X, and 2X. So the ratio of A to B to C will always be rad 3 to 1 to 2. And A, B, and C. So that is something special about the 30, 60, 90 triangle. Now, based on what we learned about right triangles, let's do a simple practice problem. Now, here is the model of this shape that we're going to use to find the answer to A and B. Now, A is saying to find the length of CA, in which we labeled as the variable B. So we have to find the measure of B. Well, we know that this is a right triangle, so we can use the Pythagorean theorem to find this length, because A squared plus B squared should equal C squared. So A squared, 8 squared, plus B squared should equal 10 squared. 64 plus B squared should equal 100. And when you subtract 64 from both sides, you get B squared should equal 36. So B is 6. So we found that CA is equal to 6. Well, AB and BC are also equal to 6. So triangle CAB is an equilateral triangle. So the length, the measure of each of the angles is 60 degrees. Because the sum of angles in a triangle is 180, and since there are 3 sides, 3 angles, it would be 60 degrees. So the measure of each of the angles in the triangle CAB is 60 degrees. So I think we have to write it out. Measure of angle CAB, 60 degrees. Measure of angle ABC, 60 degrees. And measure of angle BCA is 60 degrees because this triangle is an equilateral triangle.
So now let's look at quadrilaterals, which are polygons which satisfy the following properties. They have 4 sides, 4 vertices, and the sum of the interior angles is 360 degrees. And interior angles are basically the angles inside the shape. Now let's look at the types of quadrilaterals. We first have a square, and all 4 sides of a square are equal. And each angle is equal to 90 degrees. And each interior angle is equal to 90 degrees, and the sum of the angle is equal to 360 degrees. Because we know that a quadrilateral has to have a sum of 360 degrees, since a square is a quadrilateral. Now, if we look at the perimeter of a square, that's 4 times A, in which A is the value of one side of the square. And instead of doing 4A, we can also do 2 times rad 2 times D, where D is known as the diagonal of the square. Now moving on to another type of quadrilateral, which is a rhombus, where all 4 sides are equal, but the angles are not. So the sum of the angles are equal to 360 degrees, because it is a quadrilateral. And to find the perimeter, you can also do 4A, since like a square, it has all sides that are equal. And instead of doing 4A, you can also do 2 rad P squared plus Q squared, where P is the diagonal and Q is the other diagonal. And for the area, you can do P times Q over 2. Now moving on to another type of quadrilateral, which is a rectangle. And the opposite sides are equal, and each angle is also 90 degrees, just like a square. And we know that each angle is equal to 90 degrees, and the sum is 360 degrees. And the perimeter of a rectangle is 2 times length plus width, where length would be the longer side and width would be the shorter side. And area is also length times width, so it's this side multiplied by this side once. And so now moving on to another type of quadrilateral, which is a parallelogram. And the opposite sides are parallel as well as congruent. And the sum of the angles is equal to 360 degrees. And the perimeter is 2 times A plus B, where A is this side and B is the height. And we also know that the area is base times height, so base times the height. So we have a trapezoid, which is the last type of quadrilateral we are going to talk about, and it has one set of sides that are parallel. So it would be A and B, line A and B, that would be parallel in this case. And the sum of all of the interior angles is 360 degrees. To find the perimeter, you just add up all sides, so A plus B plus C plus D. And to find the area, you do half times A plus B times H. And A would be base 1 and B would be base 2. So these are the types of quadrilaterals that we are going to talk about.
Don't forget to subscribe and like. If you have any questions, you can email info@agoramatrical.org or comment below and we'll reply back. Maybe. And if you want to see practice things or anything about us, you can visit our website, which is basically the end of the email, but without the info and the end. So bye!